breaking news as quantum AI scans have confirmed that the interstellar object 3I Atlas is not natural at all. A strange, glowing emerald-colored object from another star system is flying through our cosmic neighborhood right now. But Earth's telescopes are being obscured by sunlight as NASA websites continue to go down during the government shutdown. This mysterious object, called 3I Atlas, has been whizzing past Mars at a terrifying 60 kilometers per second, breaking every rule in textbook comet physics. Only spacecraft orbiting Mars have been able to witness its strange opposite tail and the flickering green shell. What is this interstellar visitor really made of, and why does it seem completely immune to the solar storms that tear apart regular comets? Stay tuned, because what happens next will blow your mind if you are fascinated by the mystery of Atlas 3I and want to see more amazing cosmic stories. Hit that like button and let the universe know you are watching. Every click helps keep the search for the unknown going. Comment below and let me know where you are watching this from. I want to see where in the world is witnessing this with me. The universe has revealed a strange paradox. Just as 3I Atlas, the third interstellar object ever confirmed, glided to its closest point to the solar system, humanity's observing platforms on Earth were nearly paralyzed by unprecedented disruptions in astronomical history, with ground observatories forced to close because of the sun's dangerous position and government disruptions that stalled scientific activity. Mars suddenly became humanity's only eye on the mysterious visitor from the dark side of the galaxy. The emerald-hued rover passed within 30 million kilometers of Mars. On October 3, 2025, opening up a rare observational window, while the sun completely obscures the view from Earth, creating a blinding curtain that seems to deliberately hide Atlas. Mars's orbit reveals a gap in that curtain, turning the red planet into a unique natural observatory. 3I Atlas's approach coincided with its passage into the sun's conjunction zone, where the angle of separation is less than 10 degrees, a deadly limit for observational equipment. Even a slight deviation would send sunlight into the field of view and burn out the most sensitive optical sensors, forcing emergency shutdowns of systems worth hundreds of millions of dollars on Earth from late September to early November. The angle of elongation was compressed so severely that 3I Atlas spent 6 weeks in the 15-degree exclusion zone, rendering it a ghostly specter that would be unreachable by any modern telescope on Earth or in close orbit. As a result, at a time when every bit of data could have revolutionized humanity's understanding of this interstellar object, the most sophisticated observational network was powerless. This unprecedented observational gap left many scientists wondering whether there was something hidden around the sun that we were not allowed to see, or if it was all just a coincidence of celestial mechanics. This geometric silence inadvertently fueled conspiracy-tinged speculation in the space observing community. While Earth was blinded by the sun, Mars's orbital mechanics opened up a different stage. With an angle of separation of more than 40 degrees, sometimes exceeding 50 degrees, the red planet suddenly went from being a supporting player to being the sole direct witness to the event. Orbiters and instruments on the surface of Mars had an unobstructed view, allowing them to record any fluctuations, flashes, or unusual behavior of 3I Atlas as it penetrated the inner solar system. The scientific significance of this advantage cannot be overstated. For that brief but decisive period, Mars effectively became the only observatory in the entire solar system capable of continuously tracking a rare interstellar object. Each Mars orbit was a golden opportunity, one that, if missed, would see the data disappear forever with 3I Atlas's next step into deep space. Many space agencies have joined the observing campaign through various Mars missions, each bringing its own capabilities and perspectives, but there is no denying that the United States remains central to this sensitive scientific endeavor. Behind the veneer of international cooperation, some observers have begun to question the transparency of the data being collected, especially as the 3I Atlas incident coincided with a period of instability within the US government. This has created an information vacuum that conspiracy theorists have been quick to exploit. The European Space Agency ESA contributes two pillars, Mars Express and the ExoMars Trace Gas Orbiter. Equipped with advanced imaging and spectroscopy systems, Mars Express uses a high-resolution stereo camera and Omega spectrometer to capture multispectral images spanning the visible to the infrared, allowing detailed analysis of the structure and chemical composition of targets. The flexibility to temporarily divert observations from the main Mars mission shows that ESA can respond quickly, but also raises questions about whether it will collect sensitive information beyond official announcements. The ExoMars orbiter continues to expand its observing capabilities with the NOMAD and ACS instruments, which split incoming light into thousands of wavelength components to track noble gas and molecular signals that could reveal the object's origin. But balancing comet observations with safety constraints has some wondering if some data is being withheld for less than purely scientific reasons. The UAE's HOP orbiter, with its EXI camera and EMUS ultraviolet spectrometer, was originally designed to study the Martian atmosphere, but has proven surprisingly good at tracking bright celestial objects. HOP's flexible orbital configuration makes it particularly good at wide field imaging, a feature that has some analysts in the US concerned about the ability of other countries to collect strategic observational data before Washington. Meanwhile, China's Tianwen, one mission which possesses imaging and near-infrared spectroscopy equipment directly related to the observation campaign, has been surprisingly silent in all official statements. This lack of information has led researchers in the US to suspect that Beijing may have collected important data about 3I Atlas, but is deliberately keeping it secret for its own benefit, especially since China often emphasizes its technological superiority in interplanetary missions. This silence has inadvertently become fertile ground for speculation from the scientific community to conspiracy theorists who are always alert to any unusual information gaps. NASA's Mars Reconnaissance Orbiter, equipped with the HiRISE camera and XRISM spectrometer, is the perfect pairing for tracking comets and asteroids. But in a quirk of irony, the US government shutdown has made much of the observational data inaccessible to the public, even as technical teams quietly monitor and protect the spacecraft. The uncanny coincidence of the shutdown and the crucial approach of 3I Atlas raises controversial questions. Did the US happen to have landmark data but delay its release for fear of attracting too much attention? Or was it simply an administrative glitch that happened at the wrong time, whatever the cause? The US remains at the center of the surveillance campaign, and any new signs of 3I Atlas during this sensitive period immediately become the focus of scrutiny by the global scientific community, while continuing to feed a wave of speculation from those who believe the story runs deeper than what is being made public beyond Mars's orbit. The European Space Agency's JUICE spacecraft made flyby observations in early November. Despite its awkward geometry and instruments largely optimized for studying distant, dim targets, any data it collects will still be crucial to tracking the interstellar object's behavior as it approaches the Sun. However, given the sheer volume of data awaiting transmission back to Earth, any JICE observations won't be publicly released until early 2026, adding another layer of uncertainty to the Atlas decipherment effort. Collectively, these scattered observational assets form a multi-layered tracking network, with each mission contributing a unique spectral and geometric perspective. The delays in data releases and the complex coordination between space agencies mean the entire scientific story unfolds slowly, like a puzzle in which each new piece may hold important clues about the mysterious interstellar visitor. But perhaps the most surprising part of the observing campaign came from an unlikely place, the surface of Mars itself. At Jezero Crater, NASA's Perseverance rover took a 9-minute survey of the sky on October 2 with the Mastcam-Z camera, right? Each image was time-stamped UTC and included detailed metadata about exposure time, filters, and the camera orientation, as is standard for a routine sky survey. However, this series of images accidentally recorded a phenomenon that is difficult to explain: a faint streak of light drifting across the starry background, not matching any known artificial satellites and not showing the familiar motion characteristics of planets. If confirmed, this could be the first time in human history that an interstellar object has been directly observed from the surface of another planet. The discovery immediately attracted the attention of analysis groups in the US, at the same time raising a controversial question: did NASA know more than it announced, but was forced to keep quiet during the government shutdown? Or was it all just a coincidental slice of the universe that happened to fall into Perseverance's lens? The answer is still unknown, but the mystery is getting deeper. The verification process begins with a rigorous calibration process where each raw frame of Perseverance is put through a series of field smoothing, shadow reduction, and pixel correction steps. All forms of potential noise, from cosmic rays to internal reflections inside the lens, must be eliminated before the strange light is considered a real signal. The Mastcam-Z calibration process, familiar to NASA engineers, involves comparing ski brightness, checking lumens, and precisely aligning each successive frame to determine whether the object is an astronomical phenomenon or just an instrument trace. Once the data cleaning was complete, photometric analysis was performed using NASA SPICE data to convert the rover's line of sight into precise astronomical coordinates. 3I, Atlas's predicted trajectory based on calculations from JPL, was overlaid on the image sequence and produced a remarkable match. Parameters such as the streak's angular velocity and direction of motion matched closely to the behavior. 3I, Atlas was predicted to exhibit when observed from Jezero Crater at that exact time. Photometric analysis also showed that the light, although very faint, appeared regularly across many frames with a brightness consistent with theoretical models of a small, fast-moving halo at a distance of tens of millions of kilometers between Mars and the interstellar object. There were no unusual manifestations such as flickering, distortion, are sudden deviations, confirming that this was not a camera error, not sensor noise, and certainly not an effect of Mars's extremely thin atmosphere. The final verification step involved comparing the light's position to the predicted ephemeris, which was found to be within a few arcseconds of accuracy, perfectly in line with the accuracy of this type of observation. However, while the initial data was extremely promising, official confirmation still had to await approval from the NASA instrument team. This process, which is usually a formality, was strangely delayed by the temporary US government shutdown, leaving many to wonder whether the delay was purely administrative or whether something more sensitive was being kept under wraps just in time for humanity's rare chance to observe an interstellar visitor before Earth completely lost direct observation. Ground-based observatories captured unique features that distinguished 3I Atlas from all other known comets in the solar system. The last clear images taken from Namibia on September 25 revealed an emerald-colored halo stretching nearly 700 kilometers, 413,000 mil across, nearly twice the distance between Earth and the Moon. This eerie green hue is caused by sunlight filtering through clouds of diatomic carbon and rare reactive molecules, giving 3I Atlas an almost artificial appearance, far from the glow typically associated with traditional comets. But its structure is even more puzzling than its color. Instead of a long dust tail that extends away from the sun like typical comets, 3I Atlas has an antisolar tail that forms a wedge-shaped shape that points directly toward the sun. This strange structure, made up of large, slow-moving particles, reflects Atlas's unique interstellar orbit and makes its tail look more like a fan being pushed by wind than a typical wide-spreading trail. The fainter shells and snaking arcs from the nucleus suggest the object is undergoing periodic rather than continuous outbursts. Follow-up imaging attempts on September 27 and October 2, though hampered by increasingly bright sunlight and the weakening signal, confirmed the existence of these unusual structures. Despite the overall decrease in brightness, 3I Atlas's coma shape remained characteristic, not stretched or blurred like other decaying comets. All of this adds to the mystery surrounding 3I Atlas, an object that is both familiar in astronomical terms and yet so strange that it defies all existing models, forcing scientists to wonder whether we are observing a unique form of comet or something else entirely. The parameters describing 3I Atlas continue to astound the scientific community, to the point that many researchers in the United States openly admit that this object seems to defy every stereotype of comet classification ever built. Its speed as it passes through the solar system near Mars reaches nearly 60 kilometers per second, and theoretical models predict that it could accelerate to about 68 kilometers per second as it passes perihelion. These are numbers far beyond the speeds of typical long-period comets, which are only about 20 to 30 kilometers per second. This unusual difference has led some experts to question whether there is an unknown energy source or acceleration mechanism, or even, as some conspiracy theorists have suggested, whether the object behaves like a natural comet. It's not just its speed that makes 3I Atlas puzzling. Its orbit is also suspiciously unusual. Instead of flying in at a random oblique angle, typical of interstellar visitors flying into the solar system from all directions, 3I Atlas is traveling almost parallel to the ecliptic with only a few degrees off. This perfect alignment with the solar system's primary orbital plane is statistically extremely rare for a true interstellar object. Some American astronomers have suggested it could be a coincidence, but others have not ruled out the possibility of an unknown natural navigation mechanism or even some extrasolar source interfering with its trajectory. Estimates of its size based on its brightness and the model of its surrounding structure suggest that 3I Atlas's stellar core must be at least 5 kilometers in diameter, possibly even larger. This would put it among the largest interstellar objects ever recorded, comparable to 2I Borisov, and far exceeding the size of 1I Oumuamua. Some US analysts note that if it is indeed larger than predicted, it could carry an unprecedented amount of material from outside the solar system, making it a unique target for study. But at the same time, its large size has raised concerns from space agencies, as any object that large is likely to carry enough energy and momentum to affect the surrounding space environment. The structure of the gas and dusts surrounding the star's core adds to the mystery. Polarization data suggests the existence of concentric shells or ring-like structures, each reflecting light differently. Instead of a long dust tail like a typical comet, Tracy Atlas, Asa dense, unusually organized shell, puzzling researchers about its ejection mechanism. Some experts in the US have also mentioned the possibility of unknown physical processes or even signs that the object has experienced some harsh environment outside the solar system. These strange features, combined with the ongoing disruption of observational data due to the solar conjunction and the temporary US government shutdown, have created the perfect information vacuum for countless hypotheses to flourish, from theories about strange physical structures to more daring speculations about natural orientation. 3I Atlas is at the center of one of the most intriguing interstellar mysteries ever recorded. September 25 brought an unexpected natural experiment when a coronal mass ejection, a violent eruption of charged particles and magnetic fields from the Sun, hit 3I Atlas directly. Space weather forecasters tracked the CME's movement through interplanetary space, predicting significant interactions with the comet's extended atmosphere. Ordinary comets react vigorously to such solar particle bombardments, often exhibiting rapid outgassing, ion tail formation, and dramatic morphological changes within hours. Scientists would expect to see shock fronts, ionized gas emissions, or structural deformations as high-energy plasma collides with the comet's head. The actual response, however, was quite subtle. Post-impact observations from both ground-based and Mars-based instruments revealed very little structural change. The distinctive green halo remained sharp. The opposite tail remained wedge-shaped, and the outer shell showed no signs of sudden expansion or fragmentation. The lack of typical ion tail formation or sudden brightening has puzzled plasma physicists who expected clear signs of magnetic disturbances and enhanced ionization. This unexpected resilience raises fundamental questions about the object's internal composition and structural integrity. The lack of obvious plasma interactions suggests unusually resilient surface materials or internal structures that somehow buffer against the effects of solar weather. 3I Atlas confirmed hyperbolic orbit conclusively establishes its interstellar origin, placing it alongside two previously identified objects, one I Oumuamua and two I Borisov. However, being certain of its extrasolar origin is only the beginning of further classification challenges. Some researchers support the traditional term comet, citing the comet's blue-green crust, evidence of outgassing and layered crustal structure as supporting the conventional interpretation. Others are skeptical, pointing to the absence of a dust tail, persistent anti-tail configuration, remarkably stable structural features, and mechanical velocity curves that seem to contradict the standard comet classification. This debate has gone beyond the mere terminology, reflecting fundamental questions about the standard of evidence and the burden of proof for extraordinary claims. The scientific community's experience with one eye, Oumuamua has provided cautionary lessons about the dangers of hasty speculation. Initial observations have generated a plethora of theoretical models and hypotheses, but only the most strongly supported interpretations have withstood subsequent scrutiny. The science story surrounding 3I Atlas has opened up a unique opportunity for the community to participate in real-time astronomical research. Multiple public data streams from international missions continuously provide raw images, preliminary spectra, and initial analyses. Key sources include ESA's Planetary Science Archive, the UAE Mars Mission Data Center, and the National Archives, which regularly release FITS files in QuickView JPEG format. At the same time, independent analysis communities and the Comet observational databases have played a key role in rapidly processing and comparing new findings with predictions from JPL Horizons and other standard data sources. During periods when the official data pipeline was delayed by government shutdowns or publication restrictions, the community has played a key role releasing image stacks, photometric analysis, and orbit correction updates within hours of the raw data being posted, helping to maintain a flow of information that the official verification process could not keep up with. As 3I Atlas completes its closest approach to Mars and begins its journey toward perihelion of the Sun, fundamental questions about its nature remain unanswered. Its interstellar origin is the only undeniable truth, while virtually every other aspect of the object challenges existing theoretical frameworks. The precise chemical composition, the mechanism by which the comet's crustal structure formed, and the lack of a typical dust tail formation all require explanation. The object's remarkable resilience to the impact of a coronal mass ejection suggests interior or surface properties different from any previously studied comet. The phased release schedule of observational data from multiple international missions ensures that the scientific story will continue to develop over months or years. Some results will appear within days, while others will require extensive calibration and validation that could take until 2026. Each new dataset has the potential to solve existing puzzles or open up entirely new mysteries. The case of 3I Atlas illustrates both the power and the limitations of modern astronomical capabilities. Although humanity has a vast network of space-based and ground-based observatories, the shape of the universe and political circumstances can still create significant observing distances. The reliance on instruments on Mars for this encounter highlights the importance of distributed observing networks and international collaboration in space science. As data analysis continues and new observations emerge, 3I Atlas continues to be a testament to the universe's ability to surprise. This interstellar visitor, with its emerald glow and challenging anti-tail, is a reminder that even our most sophisticated models and expectations can be challenged by the realities of cosmic phenomena. The full story of this remarkable object will gradually unfold with each new measurement and spectrum, contributing to our understanding of these rare messengers from beyond the boundaries of our solar system